Hello viewers and my dear students. Welcome to session 3 on demo on projection of plane surfaces. Now we'll take a square lamina for the demo using this solid edge. Okay, here we'll be taking square lamina. In the previous two sessions we had taken a triangular lamina, how to do it in solid edge and all that I had shown you, and I given a detailed explanations. And now I'll take one square lamina and let you know how exactly you have to do using solid edge and all that. And you must always be aware that in different sessions of projection of planes, the different concepts pertaining to projection of plane surfaces have clearly been explained. First, you have to watch those videos first under projection of planes, covering all problems, all possible problems what could be given in the examinations have been covered under different sessions of projection of plane surfaces. Okay, this is a demo. Here I am just showing you how the same problems can be done using solid edge, because in some of the universities even today they do it on drawing sheet, but in some of the universities like VTU and all that, even in some of the private universities, even in autonomous institutions and all that, partly it will be manual, partly it will be using solid edge. That is why in general this will help you how to do any problem using solid edge. Okay, now see here. Now let us say this, I've told you this is session 3 on demo problems. I have taken a simple square lamina of size 40, has a corner on HP with a diagonal containing this corner inclined at 30 degrees to HP, and the top of this diagonal is inclined at 45 degrees to AP. Draw projection. This is problems number 6, which I have explained clearly in sessions. Projection of planes, problem 6, how to do this problem exactly I have told you. Now it's a sort of repetition, but I'm doing it along with solid edge. Using solid edge, slowly I'll be doing. That's the only difference. Okay, this explanation part I've already done in sessions pertaining to projection of plane surfaces. Okay, now you see here. See, once now open the solid edge sheet, and as I said earlier, sheet setup you just check. It should be A4, it should not be ticked and all that. Save defaults. Okay, okay. Then under format style also, these things I have been telling you. Format style. Okay, modify. Under units, it should be mm and round off to 1. Second units also mm 1. Text also Times New Roman, compulsorily Times New Roman. Font size 4 you take. It look better. Particularly dimensions will look better. And once you do this, you just say apply. Okay. Then after that, I've told you under tools also, alignment indicator and maintain relationship should be on. And at the same time, under Intellisketch, no, you see that relationship, no, endpoint, midpoint, intersection point, and all that. These things are on. Okay, these are all the basic things what you should know. And even in text also, okay, your text also, you see that it is Times New Roman 4 or 5. Okay, 4 or 5 would be convenient to you. Okay, 4 or 5 you can take for the exam. Okay, anyway, now it is a square lamina of size 40 as a corner in HP. You see here, when it is a square lamina, edge position is different, corner position is different. Hope you know that. Okay, edge position is different, corner position is different. Now it is corner in HP, you have to take corner position only. These things I have told you already. Now I have written x, y, okay, x, y, VP, HP and all that, you make it ready. Okay, now as you know, I just enlarged just to make you know better. Okay, now you see here, it is a square lamina. Square lamina, You see here, I'll take any point here. You have to draw it in corner position. It is a square lamina of sides 40. Correct, no? Square lamina of sides 40. Okay. You take any point here. Take line command. See here, this 40 you take. 40 you take. And angle, this angle is going upward is always positive. Going downward is always negative, particularly angle. Now, the internal angle of a square lamina is 45. That is why you take 45 here. Tab, okay, 45 you take. Now, once you do this, then again, this one, no. This one, let us say, okay. Now, let us say, I'll do this way. This is again 40, 40 and coming down is minus 45. In that way, you can complete that. Minus 45. Okay. Then once you are going this way, you can have the indicator, make use of the indicator. But anyway, it should be 40. 40 is already there. 45 is also already there. Carefully see. 40 and 45 you see here. When you are expecting the alignment to work, 40 and 45 is there. Directly you do. Okay. Then you join this. Did you follow? Once you do this, immediately before forgetting, okay, you see this corresponding front view, no? Corresponding front view using 0.13. You take only up to this. Take only up to this. Take only up to this. Okay. And then using 0.5, compulsorily from here to here only you join. And here to here only you join. Okay. In that way, top view and square and front view of a square lamina has been drawn. Now let me name the corners also. If you name the corners A, B, C, D. See here, let us say I'll make this as A. This is B. This is C. This is D. Okay, once you do that, when you're looking from here, because the direction of vision for front view is perpendicular to VP. When the observer is looking from here, A dash can be seen here, B can be seen, D cannot be seen. This will be B dash, D dash, this will be C dash. In that way, we'll finish off that. Okay, A dash, B dash bracket D dash, B dash bracket D dash and C dash you do. Okay, once you do this, okay, now as you know, I have drawn the top view, I have drawn the front view, and if you dimension this, you dimension only wherever possible, you just dimension, it is square 40 and internal angle and all that will be 90 degree. Because you've taken this as plus 45, this as minus 45, then waited for alignment indicator to work, and then you join C to D and all that. This is easy. Just go through what I've done. Now, as you know here, if you look to this, can you imagine one diagonal here? Here, this diagonal and this diagonal, I'll make it light. It's an imaginary diagonal. See here, in this, you see here, A, B, C, D, A, these are four sides of a square lamina. Now, it is corner position. That is why I've taken corner position. Edge position means one of the edges would have been perpendicular to XY line. Now, it is in this position, this is corner position. That means equally inclined position. That means this is 45, this is also minus 45. In that position only you have to draw. Now, if I pull this C corner up or A corner up, it will be resting on corner only on HP. Can you understand now? Now it is full triangular square lamina here. It is in true length. Now once I give a certain inclination to HP here, this lamina reduces in size because all lengths will get reduced because the inclination to HP will be there. These true lengths will become apparent lengths. Now you see here how much it has to be inclined. With the diagonal content in this corner inclined at 30 degrees to HP. You have to incline it at 30 degrees to HP. You see here what I'll do. Okay. This move take move, and this copy is there now. Copy should be there. Copy you highlight and you select the entire thing. Then take the end point here. You push it here and put escape. It will go off. Now this I have moved and copied. Okay. Move to one particular. Now it has to be rotated to 30 degree. 30 degree. Here only rotation is also there. Rotate. Okay. Rotate. But copy is not required now. Copy is not required. That's why you switch off that copy. Okay. Now select the entire thing. Take this fixed point A and moving point is C. Tilt it such that it is 30 degrees to HP. Correct? No? It is 30 degrees to HP. Rotation angle is 30 degrees to HP. You do this. Okay. Then go to escape and all that. Now, once you have done this, immediately dimension this. This, if you dimension it, it is 30 degrees to HP only. And you know very well, this front view and this front view are same. Because this I have told you in sessions also, never forget, this front view and this front view will be same because what I am seeing in the front view is AC length. AC is an imaginary diagonal parallel to VP. When I tilt this solid, in the front view, top view, be careful. I am operating only front view, top view. When I tilt the solid, it is as good as tilting AC. AC is like a line. AC is inclined at 30 degrees to HP, which is in true length. Okay, that is why the same front view, you take it here inclined at 30 degrees. It is surface inclined at 30 degrees or diagonal AC inclined at 30 degrees to HP. Both are same. Okay, that's why this front view, first stage front view and second stage front view are same. Okay, now once you do this, once you do it this way, when you're looking from the top, okay, all this because AD, AB, BC, CD and all that are all inclined. Can you understand here? That's why in the top view, it won't look like this. When it is inclined at 30 degree, it all gets reduced. Okay, now what I'll do now, I'll take this. Okay, you got the grid and all that done. Okay, now what I suggested, no, I was telling you earlier. First, you have this habit of first where are the points and all that. Now, as you know, here there is one point here. Here there is one point. Here there is one point and all that. And as you know, this point is A, this point is B, this is D, this is C and all that. Now what you do, you change it to line now. Change it to line. Okay, join from here to here. Here to here you draw. And since it is thick, this is thickness is more. Okay, you give 0.5 only, it will be better. Okay, now this is the top view. Now, see here in the text command also, take A, B, C, D. In that way, you put it at the respective places. A, B, C, D. We'll continue this in the next session. Thank you very much for watching. We'll continue in the next session. We'll continue this problem in the next session.